people who live in Canada do recommend it. You know, with the new writer, Katie, you know her?
Which one?
Caitlin.
Oh, like the Irish.
She's Irish, but she grew up in Canada. She studied there. I was like, I don't want to live anymore in Canada for the rest of my life.
Oh, really?
All right, so
Like, I want to leave.
if you keep that link handy, you can do it afterwards, or if we change the link for whatever reason.
People are
just send
weaklings.
Okay.
You know,
She's
I'm like, is it that bad?
Sign, just give this to Karen. as
Okay.
well.
Okay. Can I have a pen so I can sign this?
Of course.
Thank you.
I know.
Before Craig is out, and Dallas was sick. And Gully wasn't in at all.
I forgot.
Yes, it just says that you're allowing this.
Okay.
All right. Did you want a copy of it?
Yes, please.
Okay, I'll make a copy.
Thank you.
No problem.
I mean, it might be very well in class.
Homa, I let her know, and she said, okay.
Maybe some
Yep.
because
I'll run down there, and if they see your face, they'll listen, not to us.
There we go. You can keep this folder if you need it for anything else to do.
Thank you.
Thank you. I think we're good. Yeah. Thank you.
Are you coming?
Yeah, I'll just.
Junming, would you be able to do me a favor and count to 10? I just wanted to test a feature with your voice to see if it picks you up.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Great. So the only other technical thing I can advise you, if you wish, because again, people who might be watching this afterwards or even now, your face is going to be however you're standing in front of the podium.
Okay.
So just be mindful if you're
Backward.
Yeah, if you're a little bit further, we'll capture you. If you're a little bit up close, we just might see your neck. So,
Okay. Yeah, I have to come back and forward.
not
Backward
really.
and forward.
I think
Right,
just
yes.
maybe like a foot and a half away from you. See how I'm like still on the screen? You see my face?
Yes.
So if you get way too close, then it might cut you off.
Okay.
Okay. All right. Thank you. And you have power for both sources?
Yeah, I have a powerful one, but I think it's fine.
Okay.
Yeah, one is fine.
Okay. All right. Great job.
Okay, thank you.
Yeah, I was already the previous one and I broke actually that one. I broke the screen. There you go. I have to pay like $500. You know, I had a cable here and I closed the lid and it broke. So sensitive. Yeah. Well, it's not gonna break. Yeah, but so.
Wait, so how does that gonna save that?
No, it's not gonna save that. So now I'm careful. But
Okay.
I first thing I
The other side
yeah
is.
I want to always. So you got my hours. Morning.
Morning, I'm Junming.
Hi, I'm Greg. Nice to meet you.
Nice to meet you.
I'm good to meet you.
So
Sure.
they paid me, but it was had to go.
Well, everybody's sick today, Christina. I have 3 meetings canceled.
Yeah.
Yeah, so
Really bad this year.
everyone seems.
We'll try to keep you healthy.
Oh
Yeah,
yeah.
maybe it's good that not many people do this, so that you can get the same food We'll give a few more minutes. Let's give a couple more minutes. There's still some students. Coming up.
Yeah, no.
Or if you want coffee.
Ah.
So I didn't print out your bio, but you got your PhD at National.
Yeah, Chinese Canadian.
So if you need coffee, you can grab it.
Alright.
Yeah.
The students are not there's no one around.
This is a good first shot.
I think we'll just use that these classes.
That's something with being off campus is the students can't dart between classes. Folks here,
It
if
is
we were on
true,
main
but
campus,
the
we could guilt them into coming between classes. But
it's
seems
really
to-
like, I mean, most of the PhD students, except maybe the first year students.
We had a lot of word classes. I guess there is one.
But we want to understand your reasonings as well.
And then you do again the math and
I know, so you'll get a very nice food. That's what we think, right? But mostly I just look out. All right, 3 minutes. I guess we can start around. It's going to come in. All right, it's my pleasure to introduce Junming Huang, who is actually he's interviewing for a postdoc position here at ISI. Junming received his PhD in 2014 from Chinese Academy of Sciences, and he's spent the last around 2 years, working in Professor Barabashi's lab in Northeastern University. Those of you who are not in network science, you probably should still know about Barabashi, because when he publishes a paper, it makes it to New York Times. So I fully expect the work that you're going to be hearing about today you're going to be reading about it in Wall Street Journal, New York Times, or some in popular press in a couple of months from now. So please join me in welcoming Junming.
Thank you. Hello, everyone. So I'm Junming. Here I'm introducing one of our ongoing work that we are trying to model in the gender gap in science. This is still ongoing work and will be under review very soon. So now it's a good chance to collect feedback. All comments are welcome. So first of all, let me introduce our lab's work. That one of our major topics is quantifying the science. That we are using quantitative methods to analyze the science itself, to analyze the trend of science in the past 100 years, and see how the science emerges, how it develops, and what we can find with the rule of success. For example, we in the left bottom panel, that is Dafren's work 3 years ago, that he analyzed the dynamics of citation of each paper after it's published, and give a formula that how you can measure the impact of a paper and impact of a journal. And on the middle, on upper middle panel, that was Huawei's work that analyzed how to allocate credit to collaborators. If 5 of you co-author a paper and then the paper wins Nobel Prize, which 3 of you will win the prize finally? And in the middle bottom panel, that we are talking about the physics in a century, that we try to find the automatic algorithm to detect about 1 million physics papers in the past century and see how physics and all the subfields of physics is developing. And in the right figure, that is what I'm talking about, the gender gap. the gender gap. So the gender gap is well documented in the past 50 years, that we see in the science that men have much better performance than women. Now, if we check the number of Nobel laureates, then we see there are about 20 times more men than women. And we see the number of men and women receiving funds in the past 10 years. We still see more men than women are getting are receiving grants, and men are receiving much more grants than women. So this impels us to explore quantitatively what behind the gender gap. Here's the data we're using. That we're using the data acquired from Web of Science, that it contains all the papers in all the journal papers since 1900. And we have they have named distribution results. We are able to analyze scientists' careers, and we have about 7 million authors, and we try to label them with male and female with their first name. So finally, we have about 3 million authors. 2 million of them are male, and about 1 million are female. And we start our analysis by reporting the number of authors active in every year since 1900. By active, we mean you publish at least one paper in this year. So we see in
just to clarify, so the gender you determine from the name?
Yeah, name and country.
Name and country.
Yes, because we know that some names mean different genders in different languages.
What's the base rate accuracy of that classification method?
It's about 90 to 95%.
Is there any language that is more inaccurate than others?
Yes, Chinese, Japanese, Korean, we cannot say. Yes. So in the next figure, I will show that in some countries we cannot label. Yes.
I had two kind of questions. One is, did you have any issues with the data with only having initials for names, especially with earlier scientific papers? Or
Yeah.
did you always have a full name available, a full first name?
That's a good question. So in Web of Science, they do not record full names before 2006.
Okay.
Before 2006.
Before 2006.
So that's why there's almost nothing for 1900s.
And we borrow names from Microsoft. So Microsoft has a lot of papers also back to about 1900 or 1800. So we try to align about 40 million papers between Web of Science and Microsoft, and we borrow names from Microsoft to finish this.
The other thing I had was a comment, which is, if you're willing to make this more complicated, one interesting thing you can do is you can model the change in gender for names over time. So doing information extraction, what we found is we had dictionaries of male and female names, and over time, male names tend to become female names. So the year of publication actually changes the likelihood of a particular name being male or female, at least in Western countries.
Yes.
There are a lot of traditionally male names like Lindsay that became predominantly female.
That's true. Yes.
Strangely, it doesn't go the other way.
Yeah. So yeah, there are some names that change from male to female, like Alexis.
Hillary.
Yeah,
Yeah.
another
Yes.
one.
Yes.
So there are a lot of them that became gender neutral or predominantly
Yeah,
female
that's
over
gender
time.
neutral.
Yeah.
I mean, my name's spelled
Okay.
T-E-R-R-Y, which is often a male name.
All right, let's not derail Junming
You
right
can go
away.
on.
Second slide.
Yeah, thank you. So here we report the number of authors that are active in every year, and we see in almost all the time in the history that there are much more men than women. Sorry.
Wait, so really, so this is unbiased. This is first research author. So really, like, was going up in mid 60s, 1970? Just number of authors started going up.
Yes.
Before that, it was more or less constant. So what does that rise?
How many scientists?
I think that could be that there are very few authors there, or just they are not recorded in Web of Science.
So this is worldwide as well, right? So this
Worldwide,
is not
yes.
just American, like the space race or this.
Not America. This is all the countries, all the disciplines, science and social science.
So is the similar dynamics you observe, let's say, if you look at the APS data set, the publication? Is it
It's continuous. There's dips. World War II, for example, were the one, but
That's
it's
true, but not
continuously
like
growing.
this?
Not like this.
Not like this.
Do you think it reflects the publication bias? Just there's very few digitized records before 1970.
I think so. I have not checked this issue, but I do check the APS data, and I know there's a decrease during the World War.
But otherwise, it's pretty steady.
Yes,
growth.
yes.
Here it looks like in 1970 just
Growth, yes. Okay, and in the right panel, we also report the ratio of female authors in every year. And we see, although there's a obvious trend that we have more women now than 100 years before, we still see the ratio of women is still lower than 30%. So we still have much more men than women nowadays. And we report the ratio between men and women authors in every country that we have sufficient data. In some countries we don't report, like in China, Korea, and Brazil, we don't report because we don't have reliable gender names on them. So in most countries, we see they are colored in blue, since there are more men than women. And so we usually measure scientist academic performance by two metrics: number of papers or number of citations. So in both metrics, men have significant advantage than women. Now here we report the number of papers that a man or a woman publishes in the whole career, and we see in the right panel that overall men publish about 36% more papers than women. And then when we divide men and women into three groups, the high productive, middle product, and low product, we see there's a huge gender gap in the high productive group, that the high product men are publishing about 60% more papers than high product women. And we also, when we break down the data into 12 major disciplines and all the countries, we still see the gender gap in publications. And the case is similar for the impact. Men have more citations than women. Here we calculate impact as the number of citations a paper received within 10 years after its publication. So to avoid the bias, the comparison between old papers and recent papers. And we also notice there's a citation inflation phenomenon in the past 100 years, that paper nowadays are getting much more citations than paper 100 years ago. So we normalize them so that papers in different years are comparable. And again,
sorry, do you normalize also for the total number of papers that?
No, we don't.
So the fact that a male has more publications also explains why they also have more citations. They have a larger pool of citable items.
Yeah, so you citations per publication.
Correct. This is not citation per publication. This is just
no, this is just citations. Thank you. Okay, so
Wait, are you saying so you didn't condition on, let's say if you know male have more papers than female, right?
yes.
Then of course they are going to have more citation, even if all the papers get the same citations. But all the other things equal, is there any evidence that a single, let's say, paper authored by male would get more citations than single paper authored by female?
Yeah, that's a good question. That we check some papers by male and by female, and we see we see a phenomenon that men cite men and women cite women. And yeah, homophony. Yes. So in if I have
All you men, you should be citing women. That's what you cite my papers.
let me see if I have
Vice versa.
speaker with me today.
Hmm?
This is not
Vice versa as well. No?
It won't contribute
Okay.
as much because us women are such a small
We should
fraction.
contribute to,
So this
reducing
is
inequality.
we divide all papers into 5 groups, all with the gender of their authors, like all men, all women, and equal men and women, more men or more women. So we divide papers into 5 groups, and we see that all men papers prefer citing all men papers, all female papers prefer citing all female papers, and mixed papers prefer citing mixed papers. And yes, there's a homophily bias that men cite men papers more, and we know that men publish papers more. So this gives men an advantage that they get more citations. Okay. Sorry.
Have you investigated this by field though? Because if a field is more male, then you'll have more all male papers. So a field is more likely to cite itself. Right? So if I publish math papers and there are only males in the department, then it's likely that I will be citing other math papers, even though it's not
yeah, it's a good question. We have not done this for this figure because this is not a major part in our story, but we can see here. So the gender gap in the citation is consistent in all the disciplines. Now we don't say that in some disciplines the gender gap is more, in some disciplines the gender gap is lower. We don't say that. So in all the disciplines, including sociology, including psychology, biology, men still have much more citations than women. Okay, this is the observation. And here comes our question that I'm talking about today, that we try to explain the gender gap in performance, and why men seem better than women in performance. And widely used stereotype is that women are less productive than men, either because of women are considered less talented or women have higher family pressure. So people are stereotyping that women are less productive. But we don't agree with that. In our data set, we found that men and women are almost identically productive. So we report the number of papers men and women publish every year. That is the number of total publications divided by the year span from their first publication to the last publication. And we see overall, there's only a gender gap of 0.7% between men and women. So they're almost the same. Men and women, on average, they are publishing about 1.3 papers per year. That's the same for all the men, all the women, and that's also the same for high productive men, low productive men, and then we don't see, and that's all the same for all the disciplines. And in every discipline, we see men and women have the same annual productivity. And for countries, there are a little bit fluctuation. But overall, we don't see a consistent trend like what we saw before, that there is no gender gap. There's no consistent gender gap in the annual productivity of countries.
So this is for all the data?
All the data.
The time frame
Yes.
is everything from 1900.
Yes, yes.
But you said before, earlier slide, you said men have more papers per capita, I guess.
Yes, men have more papers in career. Now we're talking about in career, yes, in total. Now we're saying men don't have more papers per year. So this suggests us
men are working longer.
That's yes. Yes, men are working longer. So we see a huge difference in the career length. That on average, men stay about 3 more years than women. So this gives men more advantage to accumulate more papers and more citations. So this gender gap is consistent. We observe this gender gap in all the people. When we divide people into long career, low career people, when we divide people into disciplines and countries, we always see the gender gap in career length. So this suggests us that.
Sorry, what is the vertical axis on the second and last? Is the
career length.
Length of what? The career?
Career length.
And the career length is first paper, second paper, right?
First paper, last paper. Yes. Sorry. Yeah.
Hopefully, second is not the last.
Yeah, first paper and last paper. So, so when we're calculating career length, we don't calculate people that are active behind after 2010 because we have no evidence whether they have finished their career. So we exclude them all. So all the people we see here, they have finished their careers. Okay, so this suggests us a hypothesis that men's advantage in performance is just because of their advantage in careerness. And we see an example that there's two types of gender gap can be aligned. In the left panel, that is in Netherlands, we report the gender gap in careerness and the total productivity in Netherlands, and we see both gender gaps are huge. And
Sorry if I interrupted, but I make another big consideration about the way you compute the number of years, the career length, right? Because women take maternity leave, so they might be absent for years throughout their career, right? So maybe another way, more refined, to calculate the career length would be just taking the years where these authors actually published some paper, so that if there are discontinuities in between the years of their career, you also discount for that.
so we may overestimate the careerness of women.
You might,
Yeah.
I mean,
Yeah.
your career, I think this is the upper bound,
Make
right?
this even worse.
Right.
Yes.
So I think
Even
this
worse.
would be even more pronounced.
That's
You
right.
are probably adding at least, on average 1 or 2 years of career, depending on the country. The US, you have less
That's
maternity
yes.
leaves, but maybe in European countries, you can take 1 or 2 years every time you have a kid. So in some countries, it might be overly represented by a large amount. And that would make this even more drastically more, the gap more evident.
Yeah, that could be worse. Yeah, so
Actually, the same topic is here. Just you were saying before that productivity per year is more or less the same, but men are only 37% longer career, but there are 89% more papers. So
this is one country. Yeah.
That's the Netherlands.
It's true, but it's fortunate.
Yeah,
but I mean, so
It's Nordic men, so
are
much more.
Dutch men so much more productive than women, or other career? I mean, is something more than the career length, or is that the last years are much more productive? Or I mean, there's something that doesn't quite compute.
I think that's fluctuation in this country only. Yeah, in some countries, men publish more than women. In some countries,
So,
they're not.
so what's the time frame for all these numbers?
For
From-
all the time,
So from when you started studying?
from 1900.
1900.
Yes,
Oh.
but most data
Oh,
are
so you
in
have this
recent
bias. I mean,
40
things
years.
have been getting better in the last few years. So you have to break up that by
Well,
different
Most of the
time
data
spans,
comes-
because like in 1900 to 1920 would be all male, or in 1900 to 1950 would be all male, and then after that.
The
maybe
first
you just-
picture shows that basically before 1960 there are essentially no
and then
papers.
it goes
Like,
up.
yeah, but there's no papers. So what you say is true, but it accounts for maybe 0.1% of the data or something very small. So you wouldn't
I
see
see
any
what
of
you're
that.
saying.
So all the data is 1960 and last 50
Especially
years.
1970 and
Yeah.
last
Yeah.
40 years.
So before 1940, there's no. We're not saying there's zero paper. There's just a few paper. Yeah, small papers. Okay. So yeah, good questions. So here in for the have I answered the question? Sorry.
Yeah, I mean, it was a consideration more than a question.
Okay. Yeah. Yes. Yeah. We noticed that there could be pregnancy leave for women, and so some years they don't publish, but we do not exclude them because we don't want to exclude normal years that you are working but you are not publishing. So cannot distinguish them. Okay. So back to the slide there. For countries like Netherlands, that when the gender gap in careerness is huge, the gender gap in productivity is also huge. And in countries like in Cuba, that the gender gap in careerness and productivity is both small. So we try to align them in all the countries and all the disciplines, and we see a perfect alignment. That in countries and disciplines where the gender gap in careerness is large, the gender gap in productivity is also large, and this shows a linear relation. So this gives us a hint that careerness could be the only reason that explains the gender gap in performance. And we do a validation to match people. This is the score matching method. That we match people. We sample every time we sample a female scientist, we sample a male scientist with the same career length, country, and discipline. So we try to make them a twin and see what happens if we make a sample of twins. Then in this sample, there's no gender gap in careerness, and we want to see what happens with the gender gap in performance. So here's the answer that when the gender gap in careerness disappears, the gender gap in productivity and impact is largely reduced. from 36% to 8%, from 43% to 3%. So this is a huge reduction of the gender gap. And
so just go back to the slide. So you actually, in your data, you found pairs of people who from the same country
yes,
and who had the same career lengths.
same country, same discipline, same careers.
So you kind of some career, but you didn't account for like institution, whatever institution. Those are the only three factors.
Yeah, only three factors. Yes, yes. So why we control country and disciplines, we try to eliminate the bias of disciplines.
Right.
Yeah. So this suggests that if we can control one factor, the gender gap in careers, we can control a huge part of the gender gap in performance. And then this gives us another question: that why do female scientists have shorter careers? And the answer seems obvious when we check the survival rate and dropout rate of men and women in all the years. So here we report the survival rate in the left panel against the year after first publication. So we say from the first year to the last year, women have a lower rate to survive than men. And that is because women have a higher dropout rate in every year, as shown on the right panel. So this is the so-called leaking pipeline assumption, that we are losing more women than men every year, in every stage, from undergrad to PhD, from postdoc to tenure. So, but what's behind the gender difference in dropout rate? Why women have a higher dropout rate? So some people will argue that this is because of productivity. That we know there's a phenomenon called gift of productivity, that if you are more productive, you will be more chance to stay in academia. So this is called, so here we show the rate of dropout in the next year of a scientist, given his number of publications at their 25th year. So if you have a total of over 100 papers at your 25th year, and your dropout rate will be about 6%. So you'll be about 6% probability to drop out in the next year. But if you have about less than 10 years, then your dropout rate will be double. So this is easy to understand. And people will say, is that because that women are less productive, so that they are more probable to drop out? And in the previous slide, we know it's not. Women are not less productive. Men and women are almost identical productive. Now, what's the problem then with women's dropout rate? So here we report the dropout rate of men and women. Again, given their number of communicative publications in the year 20. And we see women have a higher rate to drop out, even they are at the same age with the same number of papers. And it seems that women has a systematic disadvantage to drop out, even they have the same performance. And what's worse is when we consider the gift of productivity, we see women are less rewarded. Let me explain. So we try to quantify the gift of productivity, that we compare two groups of men, the 25 low performing men and the 25% high performing men, and we compare their dropout rate, and we see the dropout rate.
Sorry. Performance is only in terms of publication.
Publication, yeah. Here we're talking about
Not
publication.
citation.
Not citation for now. Okay. So when we're talking about the publications, we see the low performing men and the high performing men, their dropout rates are 10% and 5%. So the gift of publication is 50%. That if you are more productive, you'll be rewarded that your dropout rate will be lowered by 50%. And for women, the gift is 33%. And for women, if you are very, very productive, you are very, very diligent, you will be rewarded with a lower dropout rate by 33%. So there's a structural gender gap. Now, this is not against all the women. This is against high-performing women. So here we name we name the two gender gaps in dropout rate with systematic and structural. Now the systematic gender gap is the disadvantage of all women. That all women they have a higher dropout rate than men with the same number of publications, the same age. And we also observe another type of gender gap we call structural gender gap. That for high performing women, they are suffering an additional layer of gender gap in dropout rate, that they are less rewarded with their productivity. So they are more probable to drop out than expected when we are considering their publication. Sorry.
The fact that the top quartile and the bottom quartile women have only like smaller factor between them, that could also be the opposite. Rather than punishing high performing women, maybe low performing women are artificial, encouraged to bring up. So
benefit.
Would you benefit?
Yes.
So would your argument, your reasoning change based on?
Sorry, I thought there was a huge gap between top performing women and lower performing. I mean, it
A
was
little bit less. It was
8%.
reduced. It was only 1.5 times the difference, and for men it was twice the difference. So,
Yes.
But then, so would your argument change if it was, because you don't know which way it's going, you just observe there's a difference. But
That's
you
right.
don't
Yes.
know.
Yes. So if we discuss it in a reverse way, that here we use low performing women as baseline.
It is on
Yeah. If we use high performing women as baseline, we'll see low performing women are benefiting from this.
And sorry, I missed the point. So how do you measure reward? You say high-performing women are less rewarded.
So we define reward as the decrease in the dropout rate. Okay, so here we define two types of gender gap in dropout rate, and we try to quantify how this affect the total gender gap in performance. So here's we collect about 1 million authors with career longer than 5 years, and in the year 5 we have about 30. We have 4 types of people. We have high performing women and high performing men with at least 2 papers per year. We have low performing women and low performing men with at most 0.4 papers per year. So in year 5 they have at most 2 papers. And we so this is the number of population of the 4 sets of people in year 5. And let's see what happened in 25 years. That in year 30, about 90% of them have dropped out. And we see who will survive. In the bottom, in the low performing man group, that we have 3 men survive. And in the low performing women group, we have 2 women survive. And in the high performing men, we have 5 high performing men and 2 high performing women survive. So this gives us an intuition that more women have dropped out in the 35 years. And we label them in a shadow. And we try to analyze and we align them with the gender gap, with the 2 types of gender gap in dropout rate we found before. That well, 1,040 high performing women and near 700 low performing women, the dropout because of systematic dropout gender gap in dropout rate. And there are additional about 3,000 high performing women, the dropout because of structural dropout rate, structural gender gap in dropout rate. So this doubles the number of women that drop out because of systematic gender gap in dropout rate. So this gives us an intuition that the structural gender gap in dropout rate harms high performing women much more than the systematic gender gap. So this, as a result, this changes the structure of the population structure of men and women. So see in the at the beginning we have more low performing men than high performing men, and after 25 years with the selection of gift of productivity, that men, high performing men are more probable to survive. At the end we have more high performing men than low performing men. But for women, this is not the case. The reverse is prevented by the structural gender gap in dropout rate. That at the end, we still say there are less high performing women than low performing women. This is because we are losing additional high-performing women because of the structural gender gap in dropout rate.
Can you explain, so what's the difference or your interpretation of the structural versus systematic dropout? So why do you call one systematic and one structural?
Yeah, so here's what we define here, that the systematic gender gap is the disadvantage against all the women. And the structural gender gap is the disadvantage against high-performing women.
Okay.
So here's the consequence of the structural gender gap, that we, in the right panel, we report the number of publications against the careerless. And we see for all the short career people, men and women are almost the same. They publish the same number of papers in their career if they stay less than 50 years. And for all the long career people, we see a gender gap there, that men publish more papers than women. So this shows that gender gap in performance is not there at the beginning, but it arises from zero. It arises from the structural gender gap in dropout rate, that the academia is selecting out high-performing women, which is bad.
This is a totally stupid question. Is there a difference between male and female retirement age in the country?
In the US.
No,
In US,
no.
There is in Italy.
No, I mean, and
know.
usually men retire earlier than women because of health differences. You know, women have a longer longevity and tend to.
Okay, so that wouldn't explain.
So yeah, I mean,
So I know in many European countries, women can retire usually a couple of years earlier than men. For example, in Italy, if you're an academic, if you're a professor, your earliest retirement age, I think, is 70, and for women is 67. So there is a structural difference. Men are essentially forced to stay
It only
a couple
proves
of
that
years
Italy is
more.
more biased against women.
That's the earliest age. Yeah, it does. But I mean, that without doubts. But it is also, well, that's also the earliest you can retire. But there is already there in the threshold, there is a 3 years gap in favor of men.
In China, the retire age of women is 5 years earlier than the retire age of men. So for men it's 60, and for women it's 55.
yeah, I mean, in the States, there has been a big shift in the States, which was retirement age is growing. So, you know, people born, you know, after 1960 have to work until they're 68 or 69. People born in the 40s and 50s, you know, retire at a younger age. So career life in the US is long.
Right, although academics don't really.
No, don't retire at those ages.
But I'm still thinking, in case, you know, you define low performing women as a baseline, if that would change your structural, any conclusions you make about the structural bias.
I think that would be the same. So here that we see we are losing more more high performing women. If we use high performing women as baseline, we see low performing women are benefiting from this. We still have more low performing women here.
Because they're benefiting from that.
Yes. So the conclusion would be the same. Okay, so we try to validate what if we can eliminate both type of gender gap in dropout rate. That what if there are no gender gap, there's only one type of gender gap, or there are both gender gaps. So by doing this, we force men to move out. So we cannot make up data that we cannot pretend a woman that after she quits, she keeps publishing, and we cannot create data like that. But we can delete the data, can force a man to drop out earlier than expected to see what happens if we can hack the dropout rate of men. So here's the result. Now, in the left bars, that shows the actual gender gap in publications that when we do nothing. So that's from the data that men have 36% more papers than women in Korea. And when we control the dropout rate with there's only one type of gender gap, the gender gap in publication is reduced to 50% or 7%. And when we can control both types of gender gap, the men have no advantage. So with this simulation, we simply conclude that the two types of gender gaps in dropout rate together, they can explain the gender gap in performance in publication.
How do you simulate the male dropouts in these experiments?
So for every year, and we calculate the number of publications, a cumulative number of publications of men and women, and we calculate their dropout rate. And we assume that what if the man has a higher dropout rate? So we sample some men and force them to drop out earlier.
Just by ignoring their later publications.
Yes, by ignoring their later publications. So we simulate the 4 cases. And here's the result.
Is this the average out of many simulations, or because I assume there is some stochasticity here. If you sample by chance, Laszlo, and you remove him, you will lose 20% of all the papers, right? So if you sample some super productive, by chance some super productive.
There's a chance.
Out of,
so we repeat this for about 1,000 times.
And this is the average overall.
Yes.
So if you remove an outward, are you removing the paper where he was co-authored with other paper? Like, if I have a... So
good question. So we do not exclude the papers by his co-authors. So just he is absent.
Yeah, just he never wrote the paper.
Yes, he never wrote the paper. Yes.
So he's removed by that publication from those publications.
From the publication, yes. But others will keep the same.
So, well, we have about 18, 20 minutes left. But did you look at the gift of productivity from the point of view of citations rather than papers?
Good question. This is doing. That has not been done now, but we are planning to do citation. Yeah. And we are looking forward that will be a similar result, that we can eliminate the gender gap in citations also. We hope that. Okay, so here comes the summary that we established the phenomenon of gender gap worldwide in population and academia performance, that men have consistent advantage over women. And we found that the gender gap in dropout rate can be the reason of gender gap in performance in twofold: systematic and structural. So the systematic gender gap in dropout rate, they make women have shorter careers that prevents them to accumulate more publication and citations. And structural gender gap in dropout rate, it behaves like the academia is selecting out high-performing women, and that affects the population structure of women and limits the productive women as a whole. And thank you for coming. Comments are welcome.
Thank you.
Well, I have a quick question about, again, systematic versus structural. I mean, these two things might be confounded, right? So these are not totally independent things, but some, let's say, disadvantages for the high-performing woman might have similar causes that what you call a structural disadvantage. So have you tried to actually see to what extent these two measures are correlated, or maybe try to disentangle some common confounding factors?
Yeah, so thank you for a good question. So from here, we can say they are not independent. So if they are independent, we will say they can be addictive, but they're not. So, and so when we define the two types of gender gap, so here we simply say they can be added up. But yeah, I think it's possible that they are entangled, that it is possible to really divide or to
so just to give you an example, I mean, let's say if there is a difference in the average productivity or something. So let's say male and female productivities are Gaussian, but with different, not productivity, but career length. They are Gaussians from different lengths, right? Mm-hmm. So if you talk about high-performing women, or we are talking about the upper quantiles, so then you have to deal with basically extreme value statistics rather than. So in that sense, the difference in the average will also be reflected in the difference in the extreme, right?
Yeah, that's true. Yes.
So, but you haven't done any type of analysis like that, trying to.
We do resample. So we do resample to exclude not to exclude, to reduce the influenced by the extreme points. We have some people that they have about 20.
No, I don't mean by extreme points. I mean the quantile. Let's say what you call high-performing woman is the upper quartile. I guess is 25%, right? So I'm saying that if you have some differences in the average, which I guess you call systematic difference.
Yes.
So by definition, this is also going to result in a difference in the quantiles or the extreme values of this distribution, right? So that might be one way, just maybe trying to reason about these two things.
So I'm curious about the trends. I mean, you have this aggregate for a long time period, but what I my sense is that these structural gaps are diminishing, or my hope, I don't know. I mean, if you compare the dropout rates in 1990, 91, 92, 93, I mean, hopefully those dropout rates for women are diminishing, or?
Good question. I think we done it, but I'm not sure if this is included.
Or not, I don't know. That's maybe something interesting to look at.
Let me check if I have this in the slides. So, so to answer your question, there's a good news that for both men and women, the dropout rate has been decreased in the past 30 years. Sorry, let me.
There's more scientists.
Life expectancy.
Well, I mean, the proportion is the rate. No, I mean, it's not the more scientists.
So dropout has like, longer careers.
We live longer, so yeah, should be reflected.
The men are just dropping out there. I think it has to be quite different by discipline. I mean, I go now to genetic conferences, and really more than half are female. So, I mean, computer science is still predominantly of males, but in other disciplines, I think women have overtaken
more.
Yes,
yes. We are seeing more women than men in recent years.
So this is like,
hope so.
Yes, and.
But you
it's
should
not just more; it's like more than men actually. Some disciplines.
But you showed a chart that in all disciplines that the gender gap exists for male and female. How does that not like I have a chart that percentage of women are over men in different disciplines like social work, human resources, healthcare administration, stuff like that.
But that's not academia. Academia thinks.
Social work is like
So they don't publish anything. I mean, I don't.
Social work?
There are no
social work department at USC. So
right, but there's few, but lots of people who are like social workers who they get their degree in social work and then go on to work.
Oh, so they're not
outside. They're not in academia.
I mean, this is college majors, but that doesn't mean they necessarily go on to publish anything. They don't necessarily.
So out there we have all the major disciplines: science and social science. We have psychology. We have politics. We have art, music. So we don't see any difference between them. So for social science and science, there's still a gender gap. So women are stereotyped to perform better in social sciences, but we don't see that in our data set.
So just want to mention, like in music, for example, like with professional orchestras, there's huge gender gaps. If you have, non-blind editions, if you have blind editions, there's far no gender gap.
So first of all, this was by far the most comprehensive and systematically sort of structured analysis of this topic. So thank you for doing this work. I have a sort of high level. It's not a question; it's a sort of an idea in a sense. And this goes back to Aram's question. So there are obviously many confounding factors here that might make your analysis in terms of sort of causality, to justify causality, complicated, right? And people have brought up a lot of examples that are very good. I was thinking how one could verify some of your simulations in the reality, and of course, it's impossible because you cannot force people to, retire or stuff like that, right? But economists usually do rely a lot on these so-called natural experiments. So when something happens in the real world, that creates, this control treatment groups. So I was thinking maybe there are types of natural experiments that you can study and are reflected in your data. And one example of this type of natural experiments that you could have is when, for example, in a country, the retirement age law changes, right? So in Italy, for example, I think 10 years ago or so, it went up from, for faculty, it was 68 years old for men and 65 for female, and then went up to 70 and 67. So they increased for the minimum age by 2 years. And so on. So there are this type of things that happen because of a change of law or whatever. And maybe it might be interesting to see if these reflect in some way into your data, maybe 10 years later. I'm sure that Italy wasn't the only country to do this. Throughout the 115 years of data that you have, you might have a lot of these natural experiments that occur. And maybe looking at some of these.
Or even paternity. Paternity.
Right, paternity and maternity leave laws and so on. So maybe in some countries decreased drastically or increased drastically. Maybe you can see that there are effects for one gender that are not present for another gender and so on. Yeah. So this might be sort of a gold mine for these natural experiments to somewhat verify or validate some of your simulation work that would suggest that changes in some direction are possible.
Yes, good suggestion.
And I have actually another thing for it. So like there might be actually an innocuous explanation for structural gap. Actually, it's the Simpson's paradox. People here from sick of hearing me talk about Simpson's paradox. But imagine actually you probably have the data to validate it. You probably have institutions for the people as well.
We have.
So imagine a case where highly productive women, when they actually get their first kind of tenure track positions at very prestigious, very difficult universities. They don't keep, basically, they deny tenure to all of their people. So if this is just this kind of bias, so this would say highly productive people only go to prestigious places, and suppose those deny tenure equally to men and to women.
Yes.
But high productive women would actually suffer more under that. And that could be one of the things could explain the structural gap, just because they're being selectively being and like spending their early career in the high, very prestigious places.
Yes, it could be,
Not only that, I mean, even if there is some research, I guess, showing that even in tenure decisions, women are having basically being treated more harshly than men. So it doesn't even have to be a top university. So any university, if you have only women from the top 25%.
I'm just suggesting rather than attribute something to maliciousness and bias and discrimination against women, could be something that arises purely out of that women, maybe highly productive women, are more like preferentially going to more selective departments. The most selective institutions. It could explain all of that. This kind of mirrors the classic Simpson's paradox with Berkeley undergraduate admissions, where there was a bias overall, but it was only because women tended to apply to very difficult selective departments. And once they can take that into account, then the bias disappears. Are there any other questions? Okay, well, let's thank the speaker again.
Thank you. Thank you very much.